Good morning, my beautiful people. This morning we are going to be going over the exercises 1 through 5 on the section 4.3 exercises. So I've already made a video for this, but after getting your guys' feedback, I'm remaking the videos in order to try to accommodate the suggestions you guys gave me, like giving out more examples and just kind of going into more detail was the number 2 things that I got. So more examples and more detail, and I can definitely do that for you. So for exercise 1, this question asks, which best explains how to solve the inequality x divided by 3 is less than negative 2? So the first thing I want to point out is that x over 3 is the same thing as x divided by 3. So if you're given something like x divided by 3, you can actually convert it to x over 3. And if you have x over 3, you can recognize that that is a division problem. So we've got this question asking us, what's the best way to explain how to solve this? So in that case, we need to know how to solve this. Well, the goal for solving any inequality, goal is to get the x by itself, get the variable by itself. And because when we get the variable alone, this tells us what values the variable can be to get a true statement when we actually solve out for the inequality. So let me give you an example. X can represent any number, but not any number is greater than 2 in this inequality. So even though x can be anything from negative infinity to positive infinity, x plugging in any number for x isn't always going to give us a true statement. We'll get false statements every now and then. For example, if we plugged in numbers 0, 1, 2, and 3, if we substituted 0 in for x, 0 is greater than 2, well, that's false. If we tried the number 1, 1 is greater than 2, that's also false. 2 is greater than 2, false. 3 is greater than 2, there's our first true statement. And if we continued to do that, just increasing 4, 5, we would get true and true statements every time. And so you can see that these would just continue to be true, and then going this way would continue to be false, which is where we use the graphs to represent the solutions for an inequality. If x is greater than 2, plugging in 2 for x, substituting in 2 gives me a false statement, so that's an open circle. And then the true statements are those that are greater than 2, just like the inequality says, x is greater than 2. So it would be going to the right, because numbers to the right on a number line are greater than 2. So how do we get the x by itself is now the thing. So we've discussed the goal. The goal is to get the x by itself. Why do we have that goal? Is because it describes the values of x that will give us a true statement. But how do we actually get the x by itself in this case? Well, this x, the only thing that's hanging out with the x, what's preventing it from being alone, is this divided by 3. And so we need to find a way to get rid of that 3 on the bottom of this, of what we can consider a fraction. This is x over 3. So how do we get a 3 to the top of our inequality? Well, multiplying, we can multiply by a fraction. We can multiply by 3 over 1, which is really just multiplying by 3. And that, if I multiply straight across like I do with fractions, gives me 3x over 3. And 3 over 3, if you have 3 parts of something broken up into 3, is just one whole. And so this is technically a 1x, or as we write it, just x. So multiplying by both sides by 3 is what's going to be able to cancel out those 3 on the top, the 3 on the bottom, leave me with just the x, an invisible one here that we don't show, is less than, then we have to do the same thing to the other side. Negative 2 times 3 is going to be a negative 6. And so that is how we determine our solution. This was a division problem originally, and whenever we have a division problem, we use multiplication to solve it. Whenever we have a multiplication problem, like we will in some different examples, we're going to use division to solve it. So now what you need to do, though, now that I've shown you how to solve this problem, is you need to choose the option that best describes how to solve this problem. So best describes what we did in order to solve this problem. All right, number 2 asks, explain how solving 4x, 4 times x, is less than negative 16 is different from solving negative 4 times x is less than 16. And then it gives us a bunch of options here. It wants us to fill in the blanks. The first inequality will be divided by a blank number. The second inequality will be divided by a blank number. Because the blank inequality is divided by a negative number, the direction of the inequality symbol blank be reversed. So what this is testing your knowledge on is whether you know what having a negative number attached to the variable does when we're trying to solve out these inequalities. So for this example, I'm going to do something very similar. I'm going to do 3x is less than 15 and negative 3x is less than 15. I'm going to talk about how I'm going to solve these and what the difference is going to be when I solve these out. So for all of these, like I said, where x, we need to get by itself. So we can put the x towards the bottom because we know that x on the left side is going to be by itself. How do we get the x by itself? By getting rid of everything around x, which in this case is going to be a 3 and a negative 3. Well, like we talked about earlier, this 3x is technically, we can turn anything into a fraction by putting it over 1. So we can imagine that this 3x and this negative 3x are both over 1 as a fraction. And if we wanted to get rid of the numbers around it, this 3 and this negative 3, which are both on the top, then what we need to do is get a 3 and a negative 3 on the bottom of these fractions. So what do we need to do in order to do that? Well, instead of putting them over 1, what we can do is we can divide them by 3 and negative 3, because dividing is the same thing as a fraction. When we say 8 over 4, what we're really doing to simplify that down when we say that it equals 2 is we're doing 8 divided by 8 divided by 4, which is 2. And so we can do that same thing here with these inequalities. We can divide both sides by the numbers that are attached to the x variables. Just recognize that one's positive, the other's negative. And when we do that, we can get the x by itself, because 3 over 3, like we talked about earlier, any number over itself is just one whole. So this is going to end up being a 1x, but we don't show the 1. And then on the right side, 15 divided by 3, that is going to equal 5. And because I divided by a positive number in this first inequality, I'm going to keep the sign the same, because this started off as a positive number and is still a positive number. But on the other side, 15 divided by negative 3, that's going to be a negative 5. And then negative 3 divided by negative 3, that's the 1 that we're looking for. Make sure that you are always making sure that if you start off with a negative number, to turn it into a positive x, you have to divide by a negative number as well, or multiply by a negative number. Because if we had done just 3, then this would have ended up as a negative x, which is not the values we're looking for. We're looking for the values of x. Now the thing to notice here is that this 15 started off as positive, but as you can see here, it's now negative. So the symbols of it reverse. It went from being positive to now being negative. So what we have to do in order to keep this inequality true, in order to find the values of x that make this inequality true, is we have to flip the sign. So that less than sign now becomes a greater than sign because we divided by a negative number, and it would have been the same thing if we had multiplied by a negative number. So key point to take away from this exercise 2 is that when you multiply or divide by a negative number, it's going to flip or reverse the sign, whereas multiplying or dividing by a positive number, like we did in this first inequality, does not flip the sign. All right, moving on to the next one. Which inequality can be solved using the division property of inequality, where the direction of the inequality must be reversed? So the division property of inequality, we should probably lay out what that means first. And I'm going to put here part 1 and part 2, because there are parts to this division property, particularly when we're using positive numbers, is different from when we use a negative number. So for what I would put here for part 1 is that you can divide both sides of an inequality by the same positive number, and the inequality will remain true without having to flip the sign. So that's what we did in exercise 2. If you didn't watch exercise 2, what we did is if we started off with 3x is less than 15, in order to solve out for x, we needed to put a 3 over itself, so we divided both sides by 3, and that gave me x is less than 5. So as long as I plug in a number less than 5 into the original inequality, I'll get a true statement. So but I didn't have to flip the sign in that case. So that's the part one using positive numbers, but for part two, it's a little different because, and I'll just reuse this. Whoop. That's not what I wanted to do. So part two is just a little different because part two involves negative numbers. And so what part two says is you can divide both sides of an inequality by the same negative number, and the inequality will remain true as long as, so really important there, I'm going to caps lock that one, as long as the sign is also flipped. Or reversed, we should say. That's the kind of vocabulary they use. So all in all, for this exercise 3, we can use the division property of inequality to divide both sides of an inequality by either the same positive number or the same negative number, and the inequalities will remain true as long as, if that number is negative, we also flip the sign. So going back to that first example, we had 3x, but I'm going to make that now a negative 3x is less than 15. And so what I need to do for this case is divide by negative 3 and not a positive 3, which leaves me x is greater than. I had to flip that sign. X is greater than negative 5. Because this number 15 went from being a positive to now being a negative. And because that symbol flipped, we also need to flip the inequality symbol, that comparison symbol in the middle. So what you're looking for in this problem is you're looking for which of these do I need to use division to solve. And then not only do I also need to use division, but the direction of the inequality symbol must be reversed. So in which of these 5 options is going to require division to solve it? That means it's going to be a multiplication problem.